Hi everybody, Johnny here. I hope you're doing great today. You can find more good math at jmathpage.com. Today we're going to be thinking about multiplying by 7's, and we're going to think about it in a special way. We're going to be thinking about it in terms of using an array. An array is a special way of organizing things in math so we can see things in rows and columns. It helps us think about patterns. Maybe you've seen these before. 1 times 7, 2 times 7, 3 times 7, 4 times 7, 5 times 7, 6 times 7, 7 times 7, 8 times 7, 9 times 7, and 10 times 7. Now this is your 7's table, right? And it might be really good to memorize them, but it might also be useful to think about them in terms of what an array can help us to understand about the multiplication. Now, I need to build an array. An array is going to have rows and columns, and I have to decide how many rows and how many columns. Well, I know that since I'm thinking about 7's now, I need to have 7 rows. So let me go ahead and make 7 rows. 1, 2, 3, 4, 5, 6, and 7. 7 rows. I'll number them. So we have 1, 2, 3, 4, 5, 6, 7. 7 rows. And rows make up one part of an array. The other thing that happens in an array, the other thing that makes up an array are columns, and these have to go vertically. Where the rows go horizontally, the columns have to go vertically. And how many should we make? Well, let's figure it out. Okay? Let's start with 1, 2, 3, 4, 5, 6, 7, 8, 9. You know where I'm going to stop, right? 10. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. So our array is built up of 10 columns going down and 7 rows going across. Now let's use this to understand the 7's. Now when I look at 1 times 7, what I'm saying in an array model, when I think about an array, is I'm saying I need to have 7 rows and 1 column. And how many does that make for me? Well, we're going to talk about intersections here, so let's go ahead and do that. Here's our 1 column. Here are our 7 rows. So they cross each other. Every column runs into every row. In this case, I have 1 column running into 7 rows, and every one of the places where it meets makes an intersection. And the intersection tells us about the multiplication. So if I look at 7 rows and 1 column, or 1 column and 7 rows, and the number of intersections there are, I'm going to count them. 1, 2, 3, 4, 5, 6, 7. 7 intersections. So I can say 7 rows and 1 column, or 1 column and 7 rows, gives us 7 intersections. If I go to the next one, this one says 2 columns by 7 rows, or 7 rows by 2 columns. Well, here are 2 columns, and here are our 7 rows. Let's find the intersections. And you can always be doing this yourself, just drawing out a grid like this for yourself. Now I know that I have 2 columns, so I have to count all of these, and I have my 7 rows. I know that I had 7 in the first column. Now I have to add on the next ones, right? So I have 7. Let's add on the next ones. 7, 8, 9, 10, 11, 12, 13, 14. So when I think about 2 columns and 7 rows, I end up with 14 intersections. 2 columns, 7 rows, 2 times 7 gives us 14 intersections. This next one, 3 columns and 7 rows. Okay, or 7 rows and 3 columns. Let's look this way. So here's our 3rd column. Let's go ahead and add to these. These are all the new intersections, right? Alright, we know we had 14 before, so let's add on the next set of intersections. So we have 14, 15, 16, 17, 18, 19, 20, and 21. So that's telling us that 3 columns and 7 rows, or 3 times 7, gives us 21 intersections. This one says 4 columns, 7 rows, or 7 rows and 4 columns. Well, we go to our 4th column, and let's add the intersections. Now I know I had 21 before. I have to add these on. So 21, 22, 23, 24, 25, 26, 27, 28. So I know that 4 columns and 7 rows, or 4 times 7, gives us 28 intersections. What about 5 times 7? 5 columns, 7 rows. Here's our 5th column. Let's add the intersections. Okay, we had 28 before. Let's add on 1, 2, 3, 4, 5, 6, 7. So 28 and 7 more will give us 35. Look at how many we have here. Now you can think about this as counting by 7's too. You can say 7 and 7 and 7 and 7 and 7. Okay, that's 5 7's. Or you could think this way too. You could think 5 and 5 and 5 and 5 and 5 and 5 and 5 7 times. We still end up at 35, right? So we know that 5 columns and 7 rows, or 5 times 7, gives us 35. What about 6 times 7? 6 columns and 7 rows. Here's the 6th column. Let's continue to add. Here we go. We had 35 intersections before. We're adding 7 more. 35 and 7 more will take us to 42. So we know that 6 times 7, 6 columns, 7 rows, give us 42 intersections. What about 7 columns, 7 rows? Okay. If we look here, here's our 7th column. We'll add our intersections. Okay. I had 42. I'm going to add my 7 more. 42, 43, 44, 45, 46, 47, 48, 49. So 49, we have 49 intersections. 7 times 7 gives us 49 intersections. You can see all the intersections here. Okay. What about 8 times 7? 8 columns, 7 rows. Well, here's our 8th column. We'll add our 7 rows. We had 49 before. Let's add on 7 more. 49 and 7 more will give us 56. So now we know that 8 times 7, or 8 columns and 7 rows, gives us 56. Give us 56 intersections. Okay. 9 times 7. 9th column, 7 rows. Let's see what we have here. Adding all the intersections. 56 and 7 more intersections. 56 and 7 are going to take us to 63. So 9 columns and 7 rows, or 9 times 7, takes us to 63. Oh, the last one should be pretty easy. 10 columns, 7 rows. Here's our 10th column. Let's add our intersections. Alright, we had 63, now we have to add on the 7 more. 63, 64, 65, 66, 67, 68, 69, 70. You probably knew that. So 10 times 7, or 10 columns of 7 rows, takes us to 70. Alright, so now we have the array. And it's helped us think about multiples of 7. So here are our multiples of 7. 7, 14, 21, 28, 35, 42, 49, 56, and 63, and finally 70. We can see them here too. Alright, now what I want you to do is pay attention to the array. I'm going to take these away, and I want you to call them out, or say them aloud, as I ask you which one's which. Alright? So first off, let's make these go away. Alright? And are you ready? Okay, I'm going to start at the top this time. 1 times 7 equals 2 times 7 equals 3 times 7 equals 4 times 7 equals 5 times 7 equals 6 times 7 equals 7 times 7 equals 8 times 7 equals 9 times 7 equals 10 times 7 equals. Now I'm going to mix them up. Are you ready? 5 times 7 equals 1 times 7 equals 6 times 7 equals 10 times 7 equals 2 times 7 equals 9 times 7 equals 3 times 7 equals 8 times 7 equals 4 times 7 equals, one last one, do you know which one it is? 7 times 7 equals. Let's check to see what we have. 1 times 7 equals 7, 2 times 7 equals 14, 3 times 7 equals 21, 4 times 7 equals 28, 5 times 7 equals 35, 6 times 7 equals 42, 7 times 7 equals 49, 8 times 7 equals 56, 9 times 7 equals 63, and 10 times 7 equals 70. Hope you did well with these. Now remember, an array is an arrangement that helps us to think about multiplication, and it helps us to think about it in terms of rows and columns. So columns going this way, and rows going that way. And their intersections and the grid help us to understand multiples. I hope this was helpful to you.